Hello, welcome back to JD's Science Prep. Today we are going over the formula Q equals mc delta T. As per usual, if this video helps, please like and subscribe. So in the mini lesson, it says in a system, the amount of heat gained or lost by a substance is possible to calculate using Q equals mc delta T. So let's go over what these variables actually mean. So Q is the quantity of heat gained or lost, and that's going to be measured in joules. Next up, we have the M, or mass, so that's the mass of the substance, and that will be in grams. Next up, we have C, which is the specific heat capacity of the substance. This is going to be measured in joules per gram per degree Celsius. And finally, we have the delta T, or the change in temperature, and this is going to be measured in degrees Celsius. It is worth noting the degrees Celsius can also be seen as Kelvin depending on the question you are given. Just before we go over these examples here, it is worth taking a look at the specific heat capacities of various substances. So what this means is the amount of heat it would take 1 gram of that substance to increase the temperature by 1 degree Celsius. So for example here, let's take a look at water. It would take 4.184 joules of heat to increase 1 gram of water by 1 degree Celsius. Okay, so let's take a look at some examples here. Let's try and make this make sense. Let's get to work. So example number 1. It says 120 milliliters of water is heated from 22.5 degrees Celsius to 25.6 degrees Celsius. How much heat did the water gain? So first off, I'm going to write down our formula. So Q equals mc delta T, and our mass, because water would have a density of 1 gram per milliliter, 120 milliliters will also equal 120 grams. Our C, this is where we're going to use our specific heat capacities chart. So I'm going to zoom out and zoom in on our chart. And it looks like the value of C for water in its a liquid state will be 4.184 joules per gram per degree Celsius. So let's take a look and input that. So we have 4.184 joules per gram per degree Celsius. And finally, we can also figure out the change in T, because we have a initial temperature of 22.5 degrees Celsius and a final temperature of 25.6. It looks like our change in temperature is going to be 3.1 degrees Celsius. So let's go ahead and apply these numbers to our formula. So we have Q equals the M, which is 120 grams, multiplied by our C, which is 4.184 joules per gram per degree Celsius, and that's multiplied by our change in temperature, which is 3.1 degrees Celsius. Now, what you're going to do is type that into your calculator. So 120 multiplied by 4.184, and that's multiplied by 3.1, and what you're going to get as an answer here is 1,556.45 joules. Let's take a look at sig figs here. We have 2 and 120. We have 3 in our temperature and 3 in our other temperature. So we're going to go ahead and keep 2. So our Q is going to be 1,600 joules. And if you want to take it one step further, we could say 1.6 kilojoules. Okay, so another point here, because Q is a positive value, that means that water gained heat, and that makes sense because our temperature increased from the initial to the final temperature, so this all makes sense. Let's move on to number 2. So number 2, it says a 135 gram piece of iron is heated to 96 degrees Celsius and is allowed to cool until it reaches 24 degrees Celsius. How much heat did the iron lose? So let's write out our formula again. We have Q equals mc delta T. Our mass is going to be 135 grams. Our change in temperature, let's take a quick look. So we're going to go 96, subtract 24. So the difference there is 72 degrees, but because the temperature decreased, we are going to say negative 72 degrees Celsius. And finally, we can also figure out our specific heat capacity of iron by taking a look at that chart. So let's scroll up to the chart and find iron. Looks like it's right there. So we have a C value of 0.45. So let's write that down. So we have a C value of 0.45 joules per gram per degree Celsius. And now we can go ahead and plug this into our formula. So we have Q equals 135 grams multiplied by our C, which is 0.45 joules per gram per degree Celsius. And that's multiplied by our temperature change, which is negative 72 degrees Celsius. Make sure when you're doing these questions, pay attention to positives and negatives. They will greatly impact what you get as an answer. So if you type that into your calculator correctly, what you should get as a Q value is negative 4,374 joules. And let's take a quick look at significant figures. So we have 3, 2, and 2 and 24. So we're going to go ahead and keep 2 sig figs. So our Q is going to be negative 4,400 joules. And again, if you want to take it one step further, we are going to say that iron lost negative 4.4 kilojoules. And again, this makes sense because the Q value is negative. That means iron lost heat, which makes sense as the temperature decreased from 96 degrees Celsius to 24 degrees Celsius. Let's move on to number 3. Number 3. It says a 246 gram piece of copper begins at a temperature of 34 degrees Celsius and gains 1,250 joules of heat. What is the copper's final temperature? So a little bit different here. We're not looking for the Q value. It looks like we first have to find the change in temperature and then apply that to our initial temperature of copper, which is 34 degrees Celsius. So first off, our mass is going to be 246 grams of copper. Our Q value, it says that it gains 1,250 joules of heat. So it's going to be positive 1,250 joules. And finally, the last thing we can get is our specific heat capacity, or C value. So let's go up to our table and find copper, which is going to be right here. So our C value is going to be 0.39 joules per gram per degree Celsius. So 0.39. Let's write that down. Okay, so we have all of our values. Let's see if we can figure out a way to manipulate this formula to solve for change in temperature. So first off, we have Q equals mc delta T. We want to isolate for delta T, so let's divide both sides by M and C. And what you should get as a final formula is change in temperature equals your Q over mass multiplied by specific heat capacity. So let's input our values here. So we have Q, which is 1,250 joules, divided by our mass, which is 246 grams, and that's multiplied by our C value, which is 0.39 joules per gram per degree Celsius. And what you should get if you type this into your calculator here is a change in temperature with significant figures of 13 degrees Celsius. Okay, we should keep 2 here. And we have to take it one step further because the question doesn't ask for the change in temperature, it asks for the final temperature. So I'm going to go ahead and write a quick formula for that. So we have The final temperature equals our T initial, or initial temperature, plus our change in temperature should equal our TF. So let's go ahead and input our values here. So T final equals our T initial, which was, let's refer back to the top, 34 degrees Celsius. So 34 degrees Celsius plus our change in temperature, which is positive 13 degrees Celsius. So if we type this into our calculator, if you need to, you should get a final temperature of 47 degrees Celsius. And again, this does make sense as our copper gained heat, so our temperature should increase. All right, that is the video. If it has helped, please like and subscribe. Thank you very much.